Hello everyone, welcome to the Solidity Fundamentals course. I am Anjali and I'll be your guide for this course. In today's lesson, we are going to discuss about the concept of overflow as well as underflow in Solidity. So overflow and underflow actually are problems and which have been solved in the latest version of Solidity, but I wanted to discuss this topic because it's a very important vulnerability which was there in the Solidity before 0.8.0. And as some smart contract engineers, Solidity engineers, we need to be aware of this vulnerability so that when we are writing the code, then we do not repeat the same mistakes, or we are aware that such kind of vulnerabilities exist, are possible, and so we take corrective actions to make our code foolproof. So, before discussing the concept of before seeing the practical implementation of this concept in Remix ID, let's first see what actually an overflow or underflow problem is. So, overflow actually is a situation when an unsigned integer reaches its byte size. So, what do we mean by this statement? That, for example, we have discussed that unsigned integer comes in different versions in Solidity language. We have uint starting from 8 up to 256. So by default, if you write only uint, it means uint 256. That's the default. But for other sizes, if you know that the variable is going to have the data up to a certain limit, then we can use uint 8, 16 in steps of 8, as we have discussed. So now imagine we are using a variable balance. We are maintaining the user's balance and using that unsigned integer 8. So that would mean, as we have discussed, the range. Unsigned integer means it can only take positive values, negatives are not allowed. And so we obviously, if we are maintaining a balance of ether balance of a user, we would be using unsigned integer as the type. Then it would mean uint 8 would mean the range would vary from 0, obviously the minimum number possible is 0, and the max number we had discussed was 2 raised to the power 8, which is 256 minus 1, so which is 255. So that's the maximum number. So overflow is a situation when uint or unsigned integer reaches its byte size, which would mean that in case the user's balance is exactly the maximum amount possible, for example 255, because if you want to store 256, it will not allow you, it will give you an error. We have seen it in our previous lessons also, that when you try to assign a higher value to an unsigned integer which it cannot take as per the size limit, then it will throw an error, obviously, because it's a statically typed language. But 255 is allowed, and if that balance reaches that 255 value and dynamically you try to add 1 or increment that value, what happens is, because the moment you increment that value, that will become out of range. Now in order to handle that, what Solidity was doing before 0.8 0.8.0 version was that it behaved like a cycle, and the moment you incremented that value, it became 0, so it became the lowest on the other hand. So on the other side it became 0. So similar, so what happens is that incrementing of a max byte number would return the first element, that is the 0 element. So 255 plus 1 in Solidity before 0.80 would give you a 0. And similarly, now I think you can all understand that underflow will be a situation when an unsigned integer reaches its min value. So the moment it reaches its min value, that would mean that it is already 0. And now if you try to decrement that value, it will reach to its max byte size. So if you will return decrement to a 0, then the value will be 255. Now this is a major vulnerability, and there were cases, I think back in 2018, there were some issues reported, because you see, if you are people could do, if people identify this vulnerability, you can make your balance 0, and then you can try to again call some contract function where you are decrementing your value by multiple numbers, so that once it reaches 0 and again a decrement function is called, then your balance would reach the max limit. So from 0 you become the owner of 255 ethers balance, which is a huge vulnerability. So as smart contract engineers, we need to be aware. So when this problem was identified, few libraries were also made. Safe Math is a library which is extensively used, which was actually extensively used before 8.0.8.0. So Safe Math, if you imported that library, it's a third party library. If you imported that library, it made sure that such kind of overflows and underflows do not happen. But now the most recommended thing is use the latest version of Solidity 0.8.0 onwards. This is taken care by the Solidity compiler itself. So my intention of teaching this to you is that you should be aware that older versions of Solidity have these kind of issues, and that's why you should be aware that if in case you come across some code, or you are basically complying some older versions of Solidity, then you definitely need to use some Safe Math library, or definitely need to take care of these conditions where overflow and underflow can happen, because it can lead to otherwise major vulnerabilities. Now let's move to our Remix ID, and there we can practically see this happening. Now, as you can see in Remix ID, I have created a contract with name our Overflow. So let's change the Solidity version this time. Let's make it 0.7.0. Okay. So here what I'm doing is I'm writing an unsigned integer. I'm making it public so that we are able to see the values by the button created. And then let me name it balance, simple. And let me make it uint 8 so that the range is known to us. So we know that by default, if you do not set any value here in Solidity, it will be 0. So we know now presently balance value is 0. Now let's write two simple functions. One is decrement. Okay. Let's make it public so that we can access it. And we are just decrementing the balance by 1 here. And let's write another function called increment. And here we are increasing the balance by plus plus, that is by 1. That's it. That's a simple contract. So here we need to change the compiler version. So it's already 0.80 as per the previous program. So since we have made Solidity 0.7.0, so let me select the 7.0 compiler. Okay. And now let me compile this. We save this, and yes. So now as you can see, this has compiled successfully in the 0.7.0 version. Okay. So because if you see syntax wise, there is no issue. We have followed all the rules. So it's compiled successfully. Now let's deploy this. So let me deploy and zoom this. And let's open the console. Okay. So here, now the moment I have deployed this, let me expand this. See, 3 buttons have been created. This will show you the value of balance, and this is increment and decrement. So now when I click on balance, as we can see that the initial balance comes out to be 0, right? Which is fine. But the moment I click decrement, now you can see a green tick has appeared over here in the console, which means that transaction has executed successfully, which means this balance, which was already a minimum, has been decremented by 1. Now when I check the value of balance, you see we get 255. Now that's a major vulnerability, because after 0, if you decrement it further, you get the max value, which is very wrong. So supposedly now I call the increment function. So if so, this was a problem of underflow, where it was already a minimum value, and when you decremented it, it reached its max value. So this phenomenon is called underflow. But now since it is at its max size, and now if we will try to increment it, and now you see it will become 0. See, now this is a problem of overflow. When it's already at its max size and you're trying to increment the value, it will reach its minimum value. This is overflow. So overflow and underflow both are problematic, because it will completely change the state of your balance. So this was a major vulnerability which was not addressed in this version. But now let me change the version to 0.8.0. I'm not making any other changes. So here, let me remove this contract. And here again, in compilation mode, let me save this program. And so now it says that the compiler version doesn't match because here it's 0.7.0. So I'll have to again select 0.8.0. So this is the correct compiler. So the moment I'm compiling this, let me compile this. So you see a green tick has appeared again, which is fine because obviously we know that this is a code and there is no problem syntactically in our code. So this should be compiled. Now let's deploy this. Now when I've deployed this, I'll do the same steps. First, let's check the value of balance. It is 0. Now let's call decrement. You have to look at here at the console. So here, whenever transaction is successful, a green tick appears. Now, but when after calling balance, I call decrement function. Now you see a cross appears and it says the transaction has been reverted, and it says overflow dot decrement. It was already at its overflow stage and you were trying to decrement that value. So basically this thing 0, if you decrement it, it is becoming 255 and that should not be allowed. So automatically Solidity is taking care of it and the transaction is not happening. Transaction has been reverted to the initial state. So whatever it was before, it has maintained its state, it has not changed its state. Similarly, if you had kept the value to be 255 and if you called increment here, again you will get a cross that it will not allow you to increment the max value by 1 because that's not allowed. That will be a problem of overflow. So now Solidity is taking care of it. So we don't need to be worried about it. But the only thing is we should be aware that such vulnerabilities exist before 0.8.0. And so while writing our code, we need to always check this because otherwise these can lead to major scams and problems in your code. So that's about the concept of overflow and underflow. See you in the next lesson.